Scientists studying ancient ocean sediments discovered a surprising link between the shrinking of West Antarctica's ice and the Southern Ocean's ability to absorb carbon dioxide. A new study published in Nature Geoscience finds that shifts in the West Antarctic Ice Sheet (WAIS) closely followed changes in marine algae growth in the Southern Ocean during past ice ages. However, the relationship did not work in the way scientists long assumed. The link centers on iron-rich sediment carried into the ocean by icebergs breaking away from West Antarctica. Iron typically acts as a nutrient that supports algae growth, but when researchers examined a sediment core collected in 2001 from the Pacific sector of the Southern Ocean, taken from more than 3 miles below the ocean's surface, they found something surprising. Even when iron levels were high, algae growth did not increase. To explain the mismatch, the research team examined the chemical makeup of the sediment delivered by icebergs. Their analysis showed that much of the iron was highly weathered, meaning it had been chemically altered over long periods of time. During earlier warm phases, when more ice broke off from West Antarctica and drifted northward, much of the iron reaching the ocean was in this poorly soluble form. Because algae struggled to use this type of iron, the increased supply did not lead to higher biological productivity. Based on these findings, the researchers conclude that continued shrinking of the West Antarctic ice sheet could reduce the Southern Ocean's ability to absorb carbon dioxide in the future. In waters surrounding Antarctica, iron is often the nutrient that limits algae growth. Previous research has shown that during glacial periods, strong winds carried iron-rich dust from continental landmasses into the ocean. In areas north of the Antarctic polar front, a boundary where cold Antarctic waters meet warmer waters to the north, that dust helped fertilize algae. As algae growth increased, the ocean absorbed more carbon dioxide from the atmosphere. This additional carbon uptake contributed to global cooling as ice ages began. The new study focuses instead on waters south of the Antarctic polar front. There, sediment evidence shows that iron delivery peaked during warmer periods rather than during glacial phases. The size and composition of particles in the core also revealed that the primary source of iron was not wind-blown dust, but icebergs carved from West Antarctica. As global warming continues, further thinning of the West Antarctic ice sheet could recreate conditions similar to those of the last interglacial period. Based on what we know so far, the ice sheet is not likely to collapse in the near future, but we can see that the ice there is already thinning. Continued retreat could speed up the erosion of weathered rock by glaciers and icebergs. That process could further reduce carbon uptake in the Pacific sector of the Southern Ocean compared with today, a feedback that could further amplify climate change. Thank you for watching. If you've enjoyed our videos, subscribe to our channel for there's more to come.